All right, now functions. The first thing that we're going over in Unit 2, let me just pull up my other little whiteboard here for a second to give you a big picture. So Unit 2, basically we're studying how functions work. And then also at the end of Unit 2, we're going to be going over some specifically quadratic functions. Okay, but this is separate from how functions work. Now, the previous videos that you watched, we basically covered one thing, and that's that functions can come in pieces. Okay, they do not have to be one continuous function. They can come in pieces, whatever the application deems so. Like in our first lab, when we look at the men's Olympic swim times, it does not make sense for it to be one continuous function. We want to break the data up before 1976 and after 1976. So the data reads, we can use the data better. So functions can come in pieces. The second thing we are going to learn here in this example, so example 3, is how to read functions. Okay, so we're going to learn about increasing, decreasing, and constant intervals. And then when we come back to class Thursday, and we might have a couple little videos before them, but we're going to learn how to operate with functions. Right? Basically how to add, subtract, multiply, and divide them. And there's another type of function called a composition. It's an open circle there, so we'll learn that as well. Then we're going to learn about symmetry of functions. And then lastly, how functions move. So transformations. So really the first two pieces here in 1.2.1, section 2.1, is that functions come in pieces and we want to look at how to read them. Okay, so with that being said, let's look at this graph. And just by looking at this graph, I want you to, in your head, kind of think about how many pieces this function is in. And if you saw these 3 points, you would see those are 3 breaking points or changing points where the graph changes. So that means our function here is in 4 pieces. And so what we want to do here is label our increasing intervals. I'm just going to do that with an up arrow. Our decreasing intervals, a down arrow, and then our constant intervals. Now basically this is reading a function, and you read a function just like in English we read words from left to right. You do the same thing. So I'm just going to kind of, you'll get my lack of artisticness here. I'm going to draw a little truck. Okay, so if we imagine this truck driving on this function from left to right, I'm just going to draw little arrows of the path this little truck would take. And these arrows, right, tell us where the function is increasing and decreasing, right? When the arrows are going down, decreasing. Arrows are going sideways, constant. When they're going up, increasing. So what you would expect. Now the challenging part can be to label it correctly. And what you want to do when you label these is you label, since we read it from left to right, we're looking at it via the x-axis. So you have to use the x coordinates. Maybe a shorter way to say that would be values. You want to use the x values to label it, for labeling. So if I label these points here, this point is at -1, -2. This breaking point is at 3, -2. This breaking point is at 5, 2. and yep, the 3 breaking points. So I'm going to underline the x values. And this is what we're going to use. And I'm also going to put towards the very left of the graph, I'm going to write a negative infinity, right? Because this is the very left of the graph. And then I'm going to write a positive infinity on the very right of the graph, because the graph is going to continue to go to the right. Same thing here. It'll continue to go to the left. So my decreasing intervals, because we see 2 of them, right? My first one is from negative infinity to -1. And my second one is from 2 to positive infinity, because the arrows are going down. And you're always going to use parentheses. There's no need for brackets. Remember, brackets mean it's equal to the value. So you can't say that the function is decreasing at one particular value, because you have to look at it in perspective of the values around it. So that's why we don't use brackets there. It's increasing here from 3 to 5. And then it's constant from -1 to 3. Okay? And that's going to help you with homework questions number 1 through 5. In a few of those homeworks, you're going to also have to label the domain and the range. And in this case, since my arrows are going up and like my arrows are continuing, my domain and range for both of this is all real numbers. Okay, because there's no stopping point because of these continuous arrows. But in some graphs, you might have like a solid circle, right? So that would end the domain at that x value, and it would end the range at the corresponding y value there. Excuse me. So you should be able to go into section 2.1 homework and do numbers 1 through 5, and then the end of that homework, remember, is 6 through 8, and that was on the piecewise functions.